All right, everybody, we are going through 1.6 today in intermediate algebra, and that is covering scientific notation. You should have your note sheet ready to roll, and you should be working on your bell ringers right now. So these are our learning goals that we're going to cover. We're going to write things in scientific notation, change numbers to decimals from scientific notation, and use scientific notation in problem solving. So, bell ringers. We got a few questions here. Let's see if we can kind of hammer through these. So we got repeating decimals again. So those are kind of difficult, so we got to practice those a lot. First thing you want to identify, well, maybe we want to set up our equation first. So x equals 4.56 repeating. Then we ask ourselves, how many repeating places are there? 2. So that's times 10 for every place. So this would be times 100. So we got 100x on the left. And we're multiplying this by 100, which is going to move that decimal place over 2. So you have 456. And remember, this is a repeating decimal, so this is 5, 6 repeating here too. So we got 5, 6 there, repeating. Okay? Then we subtract our two equations, and the nice thing here is that those repeating decimals are going to go away when we subtract those two. So 99x on the left, 452 on the right, and then we have a one-step equation. We divide both sides by 99. Okay, so we got 452 over 99, and then you double check to see if things can come out of that. So if I would try to take a 3 out of 452, because that goes into 99, doesn't work. Okay, 3 does not go into 452 over 99. Or you can use the fraction button that I showed you guys in class to change these back, but that is what we're going to get in the end, 452 over 99. Okay? For simplifying on B and C, we got to remember our exponent properties. If you see regular numbers that are not exponents, we're just going to use them like regular numbers. If you didn't have these exponents here, it would just be a 5 times a negative 3, which would be super easy. Okay? But we got the exponents there that complicates it a little bit. So let's do the nice numbers first. 5 times negative 3 is negative 15. And then we multiply each variable times the other one. So x times x squared, you're going to get x to the third. And then we do the y's. So y to the third times y, that's to the first. So I didn't write that over there because you have to have that first power exponent if you need it. So it'll be y to the fourth. That would be my simplified answer for that one. Okay? Then we have a lovely fraction and negative exponents. Okay? So we do the 6 and the 2 like normal. And maybe you would just want to keep a fraction here. So it'd be 3 on the top and 1 on the bottom. We just simplify that like normal. And then remember, we're moving the variables to where the larger ones are. So 2 is bigger than a negative 3. So that one's going to drop down. This is going to change to a positive 3. So we would add. So you'd have x to the fifth down there. Okay? For the y's, bigger ones up here. So we take this variable, bounce it up, and you're going to add 2 to that. So you have y to the seventh on top. Okay, and we'll make that fraction look a little bit nicer. So that is it. Negative exponents are going to move fractions, or excuse me, negative exponents are going to move variables up or down, or you move them to where the larger ones are if everything is positive or everything is negative. Okay, so what I want to do now is take care of a few of the more difficult questions that I think you had on your homework. Okay, so I have questions circled that we're going to work through here. We're going to work through a few of them. It shouldn't take a super long time. So make sure you're checking your answers on these to make sure you did them correctly. So starting with number 64. So make sure you're on number 64. Okay? This is just like the bell ringer question. We're going to work with the regular numbers, the 2 and the 6, just like regular numbers. So we multiply those since we're multiplying this. So 2 times 6 is 12. And then we work with the variables. So we add exponents for the variables. So x to the negative seventh. And then the y, so negative 4 plus 7 is y to the third. And then you can't have a negative exponent in your answer. So we got to take care of this. That's got to drop down. So 12 y to the third over x to the seventh. And remember, when you drop it down, it makes the exponent positive. Okay? That's the point of moving the variable. If you move a variable and don't change the exponent from positive to negative, you can't do that. Okay? For number 70, So we combine on top, and then we'll look to move things up and down if we need to. So I have this x to the negative 2 and x to the positive 2. So if I add those together, that gives me x to the 0. So the x's just cancel themselves out in the numerator. And we have 4 over x to the third. Okay? Don't know why the ink is changing, but it did. So 71 works the same way as our bell ringer question. We divide our front numbers like normal. And remember, this is just a negative number, not a negative exponent. So that's not going to move anything. The negative will just go in front. So if we divide these out, we're going to have a 3 on the top, the negative in the front. And then we look to move things around. So the x's are going to go up top because there's a larger number up top. All right, so this is going to bounce up and it'll add 2, making this x to the third. Okay, this is going to go down with the y on the bottom, so that's plus 4 to the bottom, so that's y to the fifth. And then my z's, the bigger one's on the top, so I'm going to have to subtract 1 from that z cubed, so that makes that z squared. All right, that's the easiest way to do that one. You look again where the larger power is, and that's where you're going to move things. And you just flip the sign when you move it. Okay, flip the sign of the exponent. All right, a few more down here, just a couple. 102 and 105. So we worked through these in class yesterday. Remember, we do PEMDAS with these to make our lives a little bit easier. We look in the parentheses first and simplify it just like we did on the last one. So 5 and 10 simplify to 1 over 2. And then we got more m's up here, so we're going to take 4 of these out of that, so we have just m on top. And then we're going to take 6 of these out of that, so we have just an n on bottom. So really, this is all we have. I don't really need the 1 up there, okay, because a 1 times an m is just an m. And now we got to finish it by cubing it. So remember, when we cube or take something to another power, or a group to a power, we distribute that through to everything. Okay, so we'll have m to the third over, well, this is the one you got to be careful with, 2 to the third is 8, and then we have n to the third. So that should be our solution for that one. That should be our simplification for that one. Okay, last one we're going to hit is 105 before we get into the main lesson. So again, simplify inside first. So we're going to have to move the x's around since there's a negative exponent up here. So that's going to drop down, making it x to the third on the bottom. And we have the y that's down there still. And then we have our negative 2 outside. So I gave you a couple different options with this one. You can give the negative 2 exponent to everything. I think that's a little more complicated. The best thing to do is just to flip the whole fraction because of this negative exponent and then change that negative exponent positive. So it would look like this to take care of the negative exponent, and now I distribute the 2 into everything. Okay, so remember, when we distribute, we multiply. So we're multiplying, we have a power to a power. That's x to the 6, y squared, and then the 9, we got to be careful with that. Just multiply 9 times 9, or 9 squared is 81. And that's what you got. All right, so if you have to finish those up, do that, and then turn these in for homework credit. And then we'll get started with the rest of the notes. Okay, so we're looking at scientific notation, all right? So what is scientific notation? That's generally where you have a number times 10 to the something. And what's the point of using it? The point of using it is when you have massive numbers. Let's say you have 25 trillion and you're multiplying it by another number. I would rather write 25 trillion as 2.5 times 10 to the 10th. Okay? It's a lot simpler to write it as 2.5 times 10 to the 10th than it is to write 10 zeros. Okay? So it's used in simplifying big numbers or very small numbers too, like 0.00005 or something like that. Okay? When we're writing things in scientific notation, this number has to be between 1 and 10. It's got to be less than 10. It can be a 1, but it cannot be a 10 because it should just be a single number, like number point something. It can't be 10. All right? So examples of scientific notation here, we got a 3.2. That's good. 3.2 times 10 to the 6th, 4.176 times 10 to the 3rd, 2.64 times 10 to the negative 2. We can have negative exponents in scientific notation. We just have to make sure that this number is not bigger than 10, because then you don't have it in true scientific notation. Okay? So how do we write these in scientific notation? Generally, if it's a larger number, you're going to have a positive exponent on your 10, okay? Because if you multiply something by 10 to the 3rd, that's 1,000, which is a pretty big number, okay? If it's a smaller number, you're really dividing by 10, or we're going to have negative exponents. So like say I had something like this, that's going to be dividing by 1,000. Or remember, if we use our exponent properties, this is 1 over 10 to the 3rd, which is 1 over 1,000. Okay? So you got to be careful with decimals and big numbers. So for every number that doesn't have a decimal, the decimal starts on the back end. Okay? And we're looking to move it so many spaces until this number is less than 10. Okay? So I move that decimal 1, 2, 3, 4 spaces. So I have 4.56 times 10 to the 4th. Whatever or however many spaces you move that, that's going to be your exponent for the 10. Okay? And then if you expanded this out again, I took 4.56 times 10 to the 4th, which is 10,000. I'm going to get right back to here. You can check these with the calculator. Right? Check your work with the calculator if you're unsure. When we already have a decimal, all right, so this is a fairly small number. That means we're going to have a negative exponent, because small numbers are going to have negative exponents. They're going to be fractions, okay? So we look to see how many places we move this to make it a number that's less than 10. So I moved it 3 places. So 3.026 times 10 to the negative 3rd, okay? If you are good at memorizing things, if I move my decimal place to the right, that's a negative or subtraction of the exponent. If I move my exponent or my decimal point to the left, like I did up here, that is a positive exponent, or you would add, okay? That's if you're good at memorizing. I kind of think it's easier just to memorize. Am I making the number bigger or smaller? If I'm making the number bigger, I have a negative exponent. If I'm making the number smaller, I have a positive exponent, okay? It's kind of backwards from what you might think normally. All right, so this one, let's check it out. Think about how many times you have to move the decimal place to make this a number that's less than 10. Or that's bigger than 1 and less than 10, I should say. So I'm only moving this to here. So I have 4.8, and I move that decimal place 1 time. So this would be 10 to the negative 1. Okay, I'm making that smaller number larger. So I have a negative exponent. Okay, so that's in general how you change things to scientific notation. Okay, and then we're going to do the opposite and multiply things out. Okay, and significant digits, we don't spend a lot of time on these. It's just, we just have these here to talk about something like this, because that 0 on the end kind of seems pointless, but the 0 is there because it's significant when we do significant digits, okay? So let's multiply these things out. And again, you could use a calculator for these, but it's a lot easier to do it in your head. Just think about how many times I'm going to move that decimal place. Since I have 10 to the 4th, I'm moving that decimal place 4 to the right. 10 to the 4th is going to make it a much larger number. So we got to make it a much larger number by moving that decimal place 4 places. So it'd be 2, 8, 3, and then we didn't have anything there, so those need to be zeros. So it's 28300. That is the number. Okay? Negative exponents are going to move my decimal left. So maybe if you need to write some notes. So positive exponent, move decimal right. You're making it a bigger number. And then same thing here, negative exponents, move left. just so you have some sort of notes to look at if you don't remember, okay? So my negative exponent here, I'm moving that left 3. So boom, boom, boom. Wherever I have nothing, like here and here, those are zeros. So 0.0038. That's what we have for that one. Okay? And we got number 6. So think about how many places you're moving the decimal and which direction. Negative going left. So we move that 1, 2, 3 to the left. So we have 0.0038. And I should have a 0 on this one because I said it's significant. If I have an extra 0 on the back end, you want to write the extra 0 on the back end when you expand it, okay? Because we should have that 0 there because it was written to begin with. Okay? Then the last things we're going to check out would be multiplication and division using scientific notation. Okay? It works similar to the way we used exponents. So we treat the regular numbers like regular numbers, and we treat the numbers with exponents using our exponent property. So 8 times 6 is 48. And then we do 10 to the 4th times 10 to the 3rd. So remember, like bases, so we add the exponents, so it'd be 10 to the 7th. So times 10 to the 7th. Okay? And now you might think you're done here, but we got to look back at this number. Is this number between 1 and 10? No, it's not. Okay? It's 48. So we need to make it 4.8. All right? So 4.8 times 10 to the something. So then remember, when we're making a larger number smaller, we would make this positive for the exponent or add to it. So we move that decimal place 1 place. So we would add 1 to this, which means this is an 8. Okay, so we have 4.8 times 10 to the 8th. And remember, you can check this in a calculator. Punch all of this stuff in a calculator to see if you have the same, like, equivalent answer. This should give you a pretty big number with 4 and 8 and lots of zeros. So 4 and 8 and 7 zeros. This should also give you 4 and 8 and 7 zeros. Okay, if you have the same thing, you did it right. Okay, looking at division. Okay, we treat our normal numbers like normal numbers. We're just going to divide those out. So 3.154 divided by 1.577 is a 2. Okay, and then we have a 10 to the 13th divided by a 10 to the 8th. Remember what we do with exponents when we're dividing the same base. We're going to subtract the exponent. So this would be times 10 to the 5th. Okay, 2 times 10 to the 5th. And I'm not going to worry about significant digits here. This would be sufficient. Okay, and we got one more, or two more, excuse me. And we're going to write our answers in scientific notation on that last one. So try these last two here quick to see if you can get the right answer. So for number 9, we're going to multiply the numbers in front. So 5 times 5.014. That gets you 25.07. And then for the tens, we're multiplying. So that means we add those exponents. So it's times 10 to the 20th. Okay? Before you're done, we got to look at this. Is it between 1 and 10? It's not. So that means we have to move our decimal place 1 again, just like we did up above. Okay, if we're moving it 1 to the left, making it smaller, that means you add 1 to that exponent, or add however many places you move. So 2.507 times 10 to the 21st. Okay, last one. So what I recommend on number 10 is multiplying these from the get-go with a calculator. So 500 times 3,500. That is 100. That is 1,750,000. All right? And then we go back to the beginning of this lesson where we change this into scientific notation. So start from the back. 1, 2, 3, 4, 5, 6. So we got 1.75 times 10 to the 6. All right, so that is your lesson on scientific notation. If you need any of this replayed, please ask for that to be replayed, and this video will be in Canvas for you later. Okay, so there's your assignment, which you're going to get a worksheet for this assignment. Please let me know if you have any questions. I hope you enjoyed the lesson. Thank you for watching.